Hello friends. In previous videos, we have discussed the overall roadmap of generative AI and started Python fundamentals. Now, let's continue with Python fundamentals. Today, we will discuss variables and data types, input and output, typecasting, operators. First, we will discuss variables and data types. First, I will explain what variables are. What is a variable? A variable is a container used to store data. I will explain it clearly with an example. Imagine you have several boxes on your desk. One box stores your name, another stores your age, and another stores your marks. Computers work in a very similar way. In Python, these storage boxes are called variables, and the information stored inside them is called data types. Think of each blue box as a variable, and inside it we store values like name, age, and marks. In Python, I will take a variable as name, and the data type as string, and the data as Anjali. The string data type, I will explain in the data types topic. Now, let's run this code in VS Code. Open VS Code in the previous file that appears. Now type this code. Name equals Anjali. And then write print name. Let's see the result. Open the terminal and select New Terminal. Then run Python program 1.py. The output will be Anjali. So, name is the variable and Anjali is the data. Why do we need variables? Without variables, we would have to type the same information repeatedly. Variables help us store data, reuse data, modify data easily. The next topic is the concept of object reference. This topic is related to variables. What is an object? Everything in Python is an object. For example, name, age, and marks are all objects stored in memory. We store data using variables, and that data is stored temporarily in memory while the program is running. Don't get confused. Whatever data we use in our programs is stored in memory as objects. All of these are objects stored somewhere in memory. Next, let's see how to create an object reference. Case 1. X equals 10. Here, X is a variable and 10 is the data. Let's execute it. You already know how to run a program, so let's type the code. X equals 10. Print X. Save the program. Remember to save the file every time you update the code. The output is 10. Now let's move to case 2. Look at the diagram. This statement creates Y and makes it reference the same object as X, not a copy of X itself. This is called a shared reference, where multiple variables reference the same object. In this diagram, the object 10 is shared, which means both X and Y reference the same object. Let's execute the code. Add Y equals X. Then print X and Y. You can see that the output prints 10 two times. Now let's move to case 3. This creates a new object for the value RAM and makes X reference this new object. The variable Y remains unchanged and still references the original object 10. Let me explain this in a simple way. First, we create X equals 10. Next, Y equals X. This creates a shared reference. Now, we assign a new object to X. X equals RAM. Python always uses the latest value assigned to a variable. So now, X references the new object RAM instead of 10. Let's execute the code. Add X equals RAM. Then print X and Y. The output will be RAM 10. Now let's move to case 4. In this case, we assign a new object to Y as well. So now, both X and Y reference new objects. What happens to the first object, 10? Since no variable is referencing it anymore, Python automatically sends it to the garbage collector. Garbage collection means Python automatically removes objects that are no longer being used. Look carefully at the diagram. X is holding the object RAM and Y is holding the object Venkat. The object 10 is no longer being used by any variable. So Python automatically sends it to the garbage collector. Simply put, the unused object gets deleted automatically. Let's see the code. Assign a new object to Y. y equals Venkat. Execute the code. The output will be RAM Venkat. So, simply, this is the concept of object reference.